Hello and welcome. In this explainer, we're going to break down the essential Python concepts that are totally reshaping the world of finance. You know, for any leader in this space, getting a handle on this shift isn't just about the tech, it's about strategy, it's about risk, and it's definitely about your competitive advantage. So, let's dive right in.
This quote really just hits the nail on the head, doesn't it? For decades, Excel has been like that trusty scooter. You know, it gets you around the block for simple tasks, and it does it just fine. But in today's world, with these massive data sets and the need for lightning-fast analytics, you can't ride a scooter in a Formula One race. You need a turbocharged engine, and that engine is Python.
All right, so why is this big shift happening right now? In this first part, we're going to look at the real-world limits of our traditional tools and see exactly why the industry is moving so fast toward a much more powerful code-based approach to stay ahead.
And the difference is, well, it's night and day. Spreadsheets, frankly, just weren't designed for the insane scale and speed that modern finance demands. Once you get to a certain size, they get slow, they're crawling with errors that are almost impossible to find, and auditing them is a complete nightmare. Python, on the other hand, was born for this stuff. It chews through huge data sets, it automates workflows, and this is the big one, it creates models that are both reproducible and auditable.
Okay, so we've got the why down. Now let's get into the what. We're going to look at the absolute fundamental building blocks of financial information in Python. Think of these as the very DNA of every single financial script you'll ever see. At its heart, it all boils down to a few key data types we use to represent financial reality. We've got integers for things you can count, like shares. We've got floats for things with decimals, like a stock price. And we use strings for any kind of text, like a customer's name or a ticker symbol. Getting these basics right is absolutely the first step to building anything reliable. First up, we have integers. Think of anything that just can't be a fraction, right? The number of shares in a trade, a unique ID for a transaction, the number of days till a bond matures. Integers give you that perfect, rock-solid precision you absolutely have to have for accounting.
Next are floats. Now these are the workhorses for most of what we do. Stock prices, interest rates, you name it. They represent any number with a decimal point. But, and you're going to want to pay close attention here, they come with a hidden risk that every single leader in finance really needs to understand.
So why is this so critical? Well, in the binary world of a computer, some decimal numbers that seem simple to us, like 0.1, can't be stored with perfect 100% precision. This creates these tiny, tiny little rounding errors. Now, one little error, it's nothing. But when you compound that across millions or even billions of transactions, it can turn into a huge problem, an auditor's absolute worst nightmare.
And this brings us to the solution. It's all about using the right tool for the job. For high-speed trading where tiny fractions don't really matter, floats are great. For exact counts, we use integers. But for the mission-critical stuff, we're talking currency settlement, tax audits, you have to insist on using a special type called decimal. It might be a little bit slower, but it guarantees the kind of mathematical purity that regulators and auditors demand. No excuses.
Of course, data doesn't just float around by itself. We need to organize it, and for that, we use things like dictionaries. They work like a super-fast digital address book. You map a unique key, like a stock ticker, to its value, like the current price. This gives you near instantaneous lookups, which is absolutely essential for any real-time trading or risk system.
All right, so we've got our data organized. Now for the fun part. How do we make it actually do stuff for us? This next section is all about control flow, the brain inside the code that lets Python make decisions and automate really complex financial logic.
Here's a perfect example from the real world, an automated loan approval system. Using simple if, elif, and else statements, we can literally write the bank's rules right into the code. The program just checks a credit score, checks an income, and then boom, instantly decides if the applicant is approved, rejected, or needs a manual review. That is rule-based automation in action.
But what about all those repetitive tasks? That's where loops come into play. A for loop is like a little robot that can go through every single asset in a massive portfolio and apply the exact same calculation, like figuring out cumulative returns to each one without you lifting a finger. This is really the heart of how we analyze things at scale.
Okay, writing a quick script is one thing, but in a real financial institution, you need something that's rock solid, that's auditable, and that your whole team can collaborate on and trust. This part is all about how we turn that basic code into professional-grade financial software.
The key to all of this is something called a function. Think of a function like a recipe.
By wrapping a standard calculation, like net present value, inside a function, we make sure that everyone, and I mean everyone, in the organization uses the exact same pre-approved formula every single time. It's modular, it's reliable, and it makes auditing way, way simpler.
Look, in the real world, data is messy. So what happens when your script is churning through thousands of records and it hits one that's missing a key piece of information? A fragile script would just crash and burn, but a robust one uses something called try-except blocks. It tries to run the code, and if it hits an error, the except block catches it, logs the problem, and just moves on to the next record. For critical systems like overnight settlement processes, this is absolutely non-negotiable.
And finally, let's talk about safety. This might seem like a small thing, but it is huge. On the left, you've got tangled, messy code that's hard to understand. On the right, you have clean code that follows industry standards. Now, this isn't just about making things look pretty. Code that's easy to read is also easy for your team to check and for auditors to validate. And that directly, and I mean directly, reduces model risk, which is the very real danger of losing millions from one tiny coding mistake.
So we've gone through the nuts and bolts, but what's the actual payoff here? Let's connect these dots. This final section shows how these fundamental Python skills translate directly from lines of code into real capital on the balance sheet. I want you to just look at this number for a second. 360,000. What do you think that represents? Well, this is the number of human hours of work that JP Morgan saved. Not once, annually. And how'd they do it? By putting these exact concepts to work in their COIN platform.
The Coin platform basically automates the incredibly tedious work of reviewing commercial loan agreements. It uses natural language processing, which is all built on these core Python ideas, to pull out key terms, check for mistakes, and flag risks in just a few seconds. This is a job that used to take thousands of lawyers, thousands and thousands of hours to do.
And look, it's not just a one-off thing at one bank. Goldman Sachs built GSQuant, a Python library that connects all their powerful internal systems to the outside world. This really shows how Python has become the lingua franca, the common language of finance. It's what allows different systems, different teams, and even different firms to all speak the same language. Which brings us to our final thought here. The value of your institution, its models, its risk systems, its secret sauce, it's increasingly being built and expressed through code. So the question for every leader today is no longer if you should get involved with this, but how. Are you equipped to lead the technical conversation that is going to define the future of your firm?